Okay, so a few more of these predicting redox reaction questions to do. Number 4 says, what are the products of the reaction of tin 2 chloride with ammonium dichromate solution acidified by hydrochloric acid? So we got all kinds of stuff here. So SN2 positive, chloride, Cl negative, ammonium, NH4 positive, aqueous. Dichromate is the Cr2O7, 2 negative, aqueous. Acidified, H positive, with hydrochloric acid, Cl negative. And of course, it would be water because of the acid. All right, we already talked about the fact that SN is both an oxidizing agent and a reducing agent. It's found on both sides of the table. We already talked about the fact that, oh, Cl's here twice. Just saying. So this is an RA. Over here I'm going to do RA and I'll link it to the water on this because water's closer. So it's an RA linked with water. Water's an RA alone. Water's an OA. All right, so then we need to go to the chart to look. We haven't had NH4 positive. And I'm sure you scoured this chart a ton and would have discovered it's not even on here, which means that it must always be a spectator. If it's not on the chart, it means it never participates in a redox reaction. But the dichromate is on the chart. It's on the chart linked with hydrogens, okay, as an OA. And then, of course, the hydrogen by itself is also an OA. All right, so now we need to find our strongest OA. And if we go back to the chart, it's going to be the dichromate. Okay, it's much higher than the hydrogen and then the water. And we need to find our strongest RA, and it's going to be the SN2 positive. Remember the Cl's and the H2O's, they're up here, so it's going to be the SN2 positive. So this one will be our SRA, this one will be our SOA. And so now writing them right off the chart, we have Cr2O7, 2 negative, aqueous, plus 14, that's why you needed to add some acid there, plus 6 electrons, going to 2Cr3 positive, aqueous, plus 7 waters. Okay, and the SN, again, be careful which SN you're using. You have to use the one that's on the RA side. It's the one that's going to the SN4 positive again, like we used the last time. Plus 2 electrons. This guy needs to get multiplied by 3, so your electrons will be balanced, and then you can add them together. So you'll have Cr2O7, 2 negative, aqueous, plus 3 SN2 positive, aqueous, plus 14 H positive, aqueous, going to 2Cr3 positive, aqueous, plus 3 SN4 positive, aqueous, plus 7 waters. Liquid. Then you go back to the chart to see which one is higher. The the dichromate is all the way up here, and the tin is down much further. This is spontaneous. All right, and just in case you've been wondering, the further apart the OA is from the RA, the further above, then the more quickly the reaction will happen. Okay, so it's not a coincidence like that some of them are more violent than others. It's based on how far apart they are. Number 5, what is the most likely redox reaction when iron metal, so Fe solid, is placed in copper 2 sulfate solution? It almost sounds like I did this one. I did. That is number 3, not number 5. What are the products of the reaction of sodium metal, Na solid, with water, H2O liquid? At least I know I'm not totally losing my mind. It was like, man, that sounds really familiar. All right, sodium metal. It's all the way down here in the bottom on the reducing agent side, Ra. We know water is going to be both an OA and an Ra, and in this one, that's it. That's all you have. So water has to be the strongest OA because it's the only OA, and sodium is definitely the strongest Ra because it's down on the bottom. When we write the half reactions down for water, it's 2H2O plus 2 electrons going to hydrogen gas and 2 peroxides. Sodium is Na solid going to Na positive aqueous plus 1 electron. This guy has to be multiplied by 2. We can add them together, so we get 2 Na solid plus 2 waters will go to 2 Na positive aqueous plus H2 gas plus 2OH. Will it be spontaneous? Remember how far at the bottom the Na was? All the way down here. And water is here. So it's definitely, it is spontaneous. And it's why you do not put sodium metal near water. Okay? Number 6A says, for each of the following, do what we've been doing. Chlorine gas, so Cl2 gas, bubbled into an iron 2, Fe2 positive aqueous, sulfate, SO4 2 negative aqueous, solution, H2O, liquid. Okay? Chlorine gas, we had already found it. It is up here, remember, right there. It's an oxidizing agent. Fe2 appears on both sides. Water appears on both sides. And remember that SO4 is linked with water as an oxidizing agent. So oxidizing, oxidizing, and reducing. Oxidizing, and water, of course, is both. Which one's going to be the strongest oxidizing? The Cl2 is close to the top. Which one is the strongest reducing? The N2 positive, close to the bottom. So we have Cl2 plus 2 electrons going to 2Cl negative aqueous. And we have Fe2 positive. Remember to use the right one. Going to Fe3 positive aqueous. You have to use the one that starts on the reducing agent side. Plus 1 electron. This needs to get multiplied by 2. So we'll have Cl2 gas plus 2 Fe2 positive aqueous going to 2Cl negative aqueous plus 2 Fe3 positive aqueous. Which one is higher up? Well, the Cl2 is all the way up here, and the Fe is right there. So it is definitely spontaneous. 6B says a zinc coating on a drain pipe. So it's going to be zinc solid on a drain pipe is exposed to air and water. So air again will be the O2 gas and water will be water, and we're assuming it's clean water. When you look on the periodic table, we're going to run out of time. Okay, we'll come back.